Hello, grade 9 students. This is a new mathematics lecture, and the title of our lesson is Square Roots or Real Numbers. What are the objectives of our lesson? In this lesson, we are going to learn how to define a square root. What is a square root? Number 2, find square roots of a perfect square. 3, find square roots of non-perfect squares. 4, perform different calculations with square roots, addition, subtraction, multiplication, and division. Expand and reduce an expression with square roots. Compare two square roots. Solve an equation in the form of x squared equal a, and how to rationalize a fraction with square roots. Number 1, quickly I will go over the first 5 objectives, since all these objectives we worked a lot on them in grade 8. Number 1, what's a square root? First, when I talk a square of a number in math, the square of any number is always positive. I make the number to the exponent 2. 4 squared is 16, 7 squared is 49, negative 3 squared, negative 3 is a negative base, so to the exponent 2 it's 9, negative 6 squared is 36. So if a is a positive number, there exists a number whose square is a. This number is called the square root of a. I denote the square root by a radical a. So this is the donation of a square root. This is a square root. It is radical a, where this symbol is called the radical and a is the radicand. The number inside, we call it the radicand. Radical a squared, to get the root of a squared, which is inside the radical, I say the square cancels the radical, so it's a. Always, of course, a is positive or greater than or equal to 0. Radical a, all of it squared, also the squared cancels the radical, and it is a. Let me give you some examples. I will move this up, and I'll give you some examples. Radical 6 squared, of course, it is radical 6 squared is 6, radical 11 squared is 11, radical 4 squared is 4, radical 2 squared is 2, radical negative 5 squared, as I said before, the negative becomes positive and it is 5. Radical negative 13 squared is 13, and radical 7 squared is 7. We have some important notes. First, if I wanted to find the radical of 0, radical 0 is 0 since 0 admits no root. Also, radical a is equal to 1. We have radical negative a. If I have a negative radicand inside when a is positive, suppose for example radical negative 5, I have negative and 5 is positive, radical 9, radical negative 13, radical negative 16, radical negative 5 squared, all these we say the radical, it does not exist. While when a is negative, radical negative into negative 5, I say negative times negative is positive, so it's radical 5. Radical negative, negative 9, negative times negative is positive, so it's radical 9, which is 3. If I have the minus outside, it has nothing to do with the radicand. So I write negative, radical a squared is a. We have numbers in math that are called perfect squares. What are perfect squares? For example, 1 squared is equal to 1, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16. So 1, 4, 9, 16, 25, 36, 49, all these numbers are called perfect squares. They are the answers of a number square. When I have a perfect square inside the radical, suppose radical a squared, directly I say the squares cancels the radical and it is a. For example, radical 5 squared is 5, radical 11 squared is 11, radical 36, the 36 can be written as a perfect squared. It is radical 6 squared where it is 6. Radical 9 is written as radical 3 squared and the answer is 3. Radical 100, it's written as radical 10 squared and the answer is 10. Radical 1, it is radical 1 squared and it is written as 1. We have sometimes to find the square roots of non-perfect squares. Can we find the square roots of non-perfect squared? Of course, yes. How can we do this? We decompose the given number inside the radical into prime factors using the prime factorization method. For example, I wanted to find the square root of 18. I ask, can I write 18 as a perfect square? No. So I make the prime factorization of 18 and I write 18 divided by 2 is 9, by 3 is a 3, by 3 is 1. So I write the prime factors of 18. Then I replace 18 by its prime factors. And then I have outside 3 radical 2. The answer is 3 radical 2. Also 24, I write the prime factorization of 24. Then I write the prime factors of 24. I replace 24 inside the radical by its prime factors. What comes outside from these factors? Only 2 squares. It comes 2 radical 6. Now, sometimes if the radicand, as I said, is not a perfect square, we can make the prime factorization. Here you can find more examples of numbers. Sometimes I might be given, for example, radical a to the power 4. How can I make the prime factorization of this? I can use two rules of power here. Either I write a to the power 4 as a power of power, it's a squared, all of it squared. Now the squared cancels the radical and it comes out as a squared, or I decompose a to the power 4 into squares of numbers. It's a squared times a squared. A squared comes as a squared comes as a, so a times a is a squared. Also, you have here many solved examples. We will start performing calculations with the square roots. The first two operations I'm talking about are addition and subtraction, since they have the same rule to apply. If I have square roots and in between I have addition and subtraction, I should always remember that I can only add or subtract radicals having similar or like radicands, the radicals having the same radicands. How can I add or subtract? I add or subtract their coefficients and I keep the radicand as it is. For example, 5 radical 2 plus 6 radical 2. I looked here, I find the plus. Here I have radical 2, I have radical 2, so I have the same radicands. So the coefficient 5 plus the coefficient 6 is 11 and I keep radical 2 as it is. Negative 4 radical 3 minus 3 radical 5. So these are having the same radicands. So negative 4 minus 3 is negative 7, of course, down. Minus 11 radical 3 plus 8 radical 3. So I have addition, same radicands. I say negative 11 plus 8 is negative 3 and I keep radical 3 as it is. Also here I add negative 4 and negative 3. Adding two negative numbers, I keep it negative and I add. So it's 4 negative 7 radical 5. 13 radical 7 minus 8 radical 7. 13 minus 8 is 5 and I keep radical 7 as it is. Now if I look at 6 radical 2 plus 8 radical 5, do I have the same radicands? No, so the answer stays as it is, 6 radical 2 plus 8 radical 5, since I cannot add different radicands. The same with minus 5 radical 11 minus 2. I keep it as it is. Now I have negative 3 radical 5 plus 2 radical 2 minus 5 radical 5. Do they all have the same radicands? No. Minus 3 radical 5 and minus 5 radical 5 have the same radicands. So minus 3 minus 5, two negatives, I keep it negative 8 radical 5, and I keep plus 2 radical 2 as it is. Sometimes if I'm adding or subtracting radicals, the radicands are not the same, but I can see that, for example, 4 radical 8 plus 7 radical 18 minus radical 32. Radical 8, radical 18, and radical 32 can be simplified. As I said before, how can I simplify radicands? I use prime factorization. So I make the prime factorization of 8, prime factorization of 18, and prime factorization of 32. This is the prime factorization of 8. Here is the prime factorization of 18. And this is the prime factorization of 32. Now I replace each one of them by its prime factors. So after replacing, I get this. Inside the first radical, 2 comes outside. So 4 times 2 radical 2. Here it comes the 3 outside. 7 times the 3 radical 2 minus. Here comes outside 2 times 2. So 2 times 2 radical 2. Now I calculate. If I look at my answers now, they are all with the same radicands. So I add or subtract coefficients. 8 plus 21 minus 4. 8 plus 21 is 29 minus 4, so it's 25 radical 2. The second calculation or operation on square roots is multiplication. In multiplication, I have 3 rules. I should, of course, understand these 3 rules and study them well to be able to apply them when needed. If I have a times radical b, a number times a radical, it is a radical b, or radical b times a, it is a radical b. For example, 3 times radical 7 is 3 radical 7. 11 times radical 5 is 11 radical 5. Radical 11 times 7, also I'm applying a radical with a number, so it's 7 radical 11. 4 radical 3 times negative 2, I apply the coefficients, then I write the radical as it is. Of course, this is a typing mistake. Sorry for the typing mistake. It is 4 times negative 2 is negative 8, and I keep radical 3 as it is. So this is a typing mistake. As I said, the rule says I keep the radical as it is. It is radical 3. Now the second rule, which is radical A times radical B. So I'm multiplying 2 radicals having different radicands. It will be radical AB, which is radical A times B. For example, radical 3 times radical 7, it's radical 21. Radical 5 times radical 2 is radical 10. But please pay attention. If you multiply the radicands and here you got a number you can simplify, you should simplify it. 2 radical 3 times 4 radical 2. So 2 times 4 is 8, and radical 3 times radical 2 is radical 6. Now the third rule, radical A times radical A, I'm multiplying 2 radicals having the same radicands. It's radical A squared, which is A. So radical 3 times radical 3 is radical 3 squared, which is a 3. 5 radical 7 times 2 radical 7. First, I multiply the coefficients. 5 times 2 is 10. Radical 7 times radical 7 is radical 7 squared. So it's 10, and the squared cancels the radical. 10 times 7 is equal to 70. 5 radical 2 times 3 radical 2, I multiply the coefficients. 5 times 3 is 15. Radical 2 times radical 2 is radical 2 squared. So the squared cancels the radical. 15 times 2 is 30. As I said, these 3 rules, the first rule, the second rule, and the third rule are very important to understand, and not only understand, very important to understand and to know how to apply these rules. Let me erase the slide first. Okay. Now, how can I divide square roots. If I have radical A over radical B, of course, this expresses division. So if the two radicals are splitted, each radicand in a radical, I can write all the fraction under the first radical. So radical A over B, or if I have radical A over B, I can split the radicands to radical A over radical B. For example, radical 7 over radical 12, I write them in prime factorization. Then I simplify the second one. After that, I write half radical 7 over 3, radical 15 over radical 6, and I can write them under the same radical to simplify 15 with 6 by 3, and it's radical 5 over 2. Radical 36 over radical 16, it is radical 6 squared over radical 4 squared. Since 36 and 16 can be written as a perfect squared, so it's 6 over 4. Now I can simplify 6 and 4 by 2, so it's 3 over 2. Radical 25 over 3, I write 25 as a perfect square, then it is 5 over radical 3. Please pay attention to this. If I have inside the radical times, I can split the radicands. So radical A times B, I can write it radical A times radical B. Also in division, if I have the same fraction inside the same radical, I can split the radicands to radical A over radical B. This can be done in multiplication and division, but I cannot do it in addition and subtraction. So radical A plus B cannot be written as radical A plus radical B, and radical A minus B cannot be written as radical A minus radical B. This is very important. Number 5, expand and reduce an expression with the square roots. We should apply here the rules of expand we studied last year in our lesson algebraic expression. To expand an expression, we use one of the two rules. Either I use the multiplication rules or the remarkable identity rules. Multiplication rules, I have two. M into A plus or minus B, if I have a binomial multiplied by something outside it, then this thing M is multiplied by A, it gives MA, M multiplied by B plus or minus MB. This is the first multiplication rule, which I call it one for all. If I have two binomials multiplied together, this is all for all. I multiply all I have in the first binomial by all I have in the second binomial. So M times A is MA, plus or minus M times B is MB, plus N times A is NA, and N times B is NB. The remarkable identity rules are three rules, which are the first rule: if I have an expression written A plus B, all of it squared, I write it A squared plus 2AB plus B squared. A minus B, all of it squared, it's written A squared minus 2AB plus B squared. A minus B into A plus B is written as A squared minus B squared. Now I should expand 2 radical 3 into 5 plus radical 3. I see a binomial multiplied by 2 radical 3. So I apply the first rule of multiplication, one for all. 2 radical 3 times 5. Here I will be applying the multiplication rules I talked about before, the three rules. First, I multiply 2 times 5, 10, and I keep radical 3 as it is. Positive times positive is positive. Radical 3 times radical 3 is radical 3, all of it squared. So now I can continue calculation. So it's 10 radical 3 plus 6, which is 10 radical 3 plus 6, which is written as it is. Can we add 10 radical 3 with plus 6? Never. This has a radical. This is only a number. These are different from each other. So I cannot write 16 radical 3. I cannot add different things together. Now the second rule, which is the rule of all for all. So I multiply 3 radical 3 with radical 3 and minus 1. Then I multiply plus 2 with radical 3 and minus 1. Radical 3 times radical 3 is 3 radical 3 squared. Radical 3 times minus 1 is minus 3 radical 3. Plus 2 times radical 3 is plus 2 radical 3. Plus 2 times minus 1 is minus 2. I should check if I can simplify. Yes, I can simplify more. Since here the squared cancels the radical, so it's 3 times 3. Minus 3 radical 3 plus 2 radical 3 are same radicands, so I can add or subtract the coefficients. Minus 3 plus 2 is minus radical 3. Minus 1 radical 3 means minus radical 3, and I keep minus 2 as it is. Now 3 times 3 is 9, so 9 and minus 2 are 7 minus radical 3. Now I see parentheses square and inside I have a plus. So I apply the first remarkable identity, which is a squared, which is radical 5 squared, which is 5. I'm applying the rule directly. Plus 2ab, I multiply radical 5 plus 2 is 2 radical 5 plus 2 which times 2 which is 7 radical 5. B squared which is 2 squared 4. Now 5 plus 4 is 9 plus 4 radical 5. 1 minus 2 radical 3 all of it squared. Also I apply the second remarkable identity. 1 minus 4 radical 3 plus 2 radical 3 all of it squared, which is 12. I add 1 plus 12, which is 13 minus 4 radical 3. In the last one, I should not apply all for all here. Please pay attention. Yes, I have two binomials multiplied together, but the same terms I have in the first and the second binomial. Between I have plus and minus, so here I apply a plus b into a minus b, which is a squared, the 3 squared, minus b squared, minus radical 2, all of it squared, so it's 9 minus 2, which is 7. How we compare square roots? If I'm comparing square roots to know if greater than, equal, or less than. If I have radical A and radical B, I should square both sides. So I make radical A squared and I make radical B squared. This gives me A compared with B. Now, radical 7 and radical 10. So I say I should square radical 7 and radical 10. Radical 7 squared is 7 and radical 10 squared is 10. So 7 is less than 10, then radical 7 is less than radical 10. The same, 5 and radical 17. I square both. 5 squared is 25. Radical 17 squared is 17. 25 is greater than 17. So 5 is greater than radical 17. This is the same. I square all 3 radical 2 and all 2 radical 3 and I compare. This is in the case of positive. While in the case of negative, we know in the negative side of the numbers, as we go farther from 0, the number becomes smaller. So after comparing negative radical 6 with negative radical 7, I make them squares. I compare 6 and 3. Since 6 is greater than 3, so 6 is less, negative radical 6 is less than negative radical 3. Why? As I said, in the negative, as the number becomes bigger, it is smaller. Okay? Now, this is very important. If I'm asked to simplify radical a plus b all of it squared, I cannot directly say the square cancels the radical and it comes out as a plus b. Why? Since a plus b is a binomial. So when simplifying binomials with the squares, I should pay attention. If the sign inside is positive, then the radicand square is positive. So whatever a and b are, if I add them, they will give me a positive number. So to find the square root of a positive number, it comes out as a plus b. For example, radical 5 plus 3, all of it squared. Since I have plus inside, so this is positive, so the square cancels the radical and it comes out as radical 5 plus 3. The same, radical 1 plus 2 radical 3, all of it squared. Since it's positive, the squared cancels the radical, so it's 1 plus 2 radical 3. Now in the case of negative, What do I say? I say a minus b, radical a minus b, all of it squared. I say if a is greater than b, then the squared cancels the radical and it comes out as a minus b. So if a is greater than b, it comes out as a minus b. For example, radical 5 minus 2 radical 3 squared. I should compare 5 and 2 radical 3. As I said, how can we compare them? We make them squares. 5 squared is 25 and 2 radical 3 squared is 12. Since 25 is greater than 12, then I say that 5 is greater than 2 radical 3, so it comes out as 5 minus 2 radical 3. Now radical 11 minus 4, all of it squared. Since I have minus, I should compare radical 11 and 4. I square both, so radical 11 squared and 4 squared. It is 11 compared to 4, to 16, since 11 is less than 16, so it comes out converted. So it will come out as, 4 minus radical 11. So I switch them and it comes out as a 3 minus radical 11. Let me do it again with you. Of course, this is a typing mistake. Let me do it again with you. So I'm comparing radical 11 and 4. If I compare them by squaring both, this is 11 and this is 16. So radical 11 is less than 4. Since the first is less than the second, then it comes out as b minus a. So I switch them. It comes out as 4 minus radical 11. Now, to rationalize the denominator of a fraction means get rid of the radical in the denominator. To rationalize the denominator of a fraction, always the word rationalize means I will be having a fraction and in the denominator I have a radical. Rationalize means I should get rid of the radical in the denominator. How can I do this? To rationalize a fraction, we multiply the fraction by the conjugate of the denominator. For example, if in the denominator I have radical a, what's the conjugate of radical a? It's a radical a. The conjugate of a radical b, I have to work only with the radical, so it's radical b. The conjugate of radical a plus b is radical a minus b. The conjugate of radical a plus radical b is radical a minus radical b. Also, the conjugate of radical a minus b is radical a plus b. Radical a minus radical b is radical a plus radical b. For example, 2 over radical 5. So since I have a radical in the denominator, I should rationalize. So 2 over radical 5, I multiply it by a fraction, the conjugate of the denominator. So I multiply it by radical 5 over radical 5. 2 times radical 5 is 2 radical 5. Radical 5 times radical 5 is radical 5 squared. Radical 5 squared is 5, so 2 radical 5 over 5. Now, if I look at my fraction, the denominator is rationalized. No radical. 5 radical 7 over 3 radical 2. So I multiply by the conjugate, which is radical 2 over radical 2. 5 radical 7 times radical 2 is 5 radical 14. 3 radical 2 times radical 2 is a 3 radical 2, all of it squared. Now I simplify the denominator. So radical 2 squared is 2. So it is 5 radical 14 over 6. Now it is rationalized. 5 over 2 plus radical 3. Now in the denominator I have a radical 3, but this is a binomial in the denominator. To multiply by the conjugate of the denominator as a binomial, I keep them as they are, but I change positive to negative. So what's the conjugate of 2 plus radical 3? It is 2 minus radical 3. So 5 over 2 plus radical 3 is multiplied by 2 minus radical 3 over 2 minus radical 3. Now I multiply 5 into 2 minus radical 3 over 2 radical 3 into 2 minus radical 3. I multiply. 5 times 2 is 10. I apply 1 for all. 5 times negative 3 is negative 5 radical 3. Now in the denominator, I see a remarkable identity 3. A plus b into a minus b, which is a squared minus b squared. Now I get the answer. So it is rationalized. Similarly here, the conjugate of 4 radical 3 minus radical 5 is 4 radical 3 plus radical 5. I multiply the numerator times the numerator, and as you can see, I do not multiply while they are each one of them on a fraction. I write 5 radical 2 into 4 radical 3 plus radical 5. This is very important. Then I multiply denominator times denominator. Since they are binomials, I multiply them between parentheses. Here I apply 1 for all, and here I apply remarkable identity 3. So this is the answer. I will see it is 43 and it is rationalized. The same here, the conjugate of 2 radical 3 plus 1 is 2 radical 3 minus 1 over 2 radical 3 minus 1. I multiply numerator 1 by numerator 2. This is a binomial times a binomial, so I write this inside parentheses into inside parentheses, and I write denominator times denominator, each one inside parentheses. Now here I apply all for all, and here I apply remarkable identity 3. I reduce if I can, then I get the answer. Over 11 is a rationalized denominator. Finally, how can I solve an equation in the form of x squared equal a? Last year, if I wanted to solve x squared equal a, for example, x squared equal 9, I say it's a second degree equation. I should get 9 to side 1, so side 2 becomes 0. So I have x squared minus 9 equals 0. Then I factorize. After that, I get a product equation. Then I solve. I will teach you an easier way to solve equations in the form of x squared equal a. To solve an equation in the form of x squared equal a, there are 3 cases. If a is positive, so if this number is positive, then my equation has 2 solutions. They are x equal radical a or x equal minus radical a. For example, x squared equal 9. 9 is positive, then this equation has 2 solutions. I make square root of both sides. Radical x squared equal, this has 2 solutions, one positive, one negative, plus or minus radical 9. So this gets out as x and this gets out as a 3. So x equal 3 or x equal minus 3, 2 solutions. If a is equal to 0, so if this is equal to 0, then x squared is equal to 0, then x is equal to 0, it has one solution, which is x equals 0. If a is negative, then x squared is equal to minus a has no solution. So x squared equal minus a has no solution. So if this is negative, then my equation has no solution, because I can never have square equal to negative. Always the square should be positive. X square equal minus 4. A is equal to minus 4, which is negative, then x squared equal minus 4 has no solution. Suppose I gave you the equation x squared equals 7. 7 is positive, then I make the square root of both sides. This has 2 solutions. Then radical x squared is equal to radical 7, or radical x squared is equal to minus radical 7. 7 cannot be simplified, so x is equal to radical 7 or x is equal to minus radical 7. This was our lesson for the coming weeks, which is the square roots, as I said, or the real numbers. Please watch the video well. And after watching the video, if you have any question, please contact me. And I want you to solve all the examples in the slides you have seen, because these are very helpful. Thank you.